this is for the real scalar field. So I have only one A and A dagger. So I have one pair of A and A dagger. If I write down its complex conjugate, for example, if I try to do that, then this term will come here, A, this will become minus of that, this will come here, A dagger, and this will become plus. Okay, iota becomes e to the plus I. So by the definition, it is clear that this phi of x is a real scalar. Okay, but if I have a complex scalar field, then I would replace this by another symbol, let us say B dagger, and then its complex conjugate would be different. So I would have B, I will write it again, okay? Now, but here, the only logic that I wanted to give, you can see an analogy of this, extension of this beyond quantum mechanics. What we did in quantum mechanics, we said this equal to 1, this equal to 1. Here we did not have explicit dependence on the momentum, right? But this was a linear expansion of. So here, in any case, in quantum mechanics, you will have a sum and not an integration. Okay? All right? So that is what we had in harmonic oscillator, one-dimensional harmonic oscillator. But here, then, so this is what is called as the positive frequency part. So this always contains an elation operator. Okay? And this is negative frequency part, and this always contains a creation operator. All right? Okay, so then, and this along with that, without saying, it is always implied that this, by this end, let me better use this symbol. Actually, I prefer this. So I put any expression between this, it means it's normal order. So you can see, if I have phi plus here and phi minus here, then, and I want to do normal ordering, then this would be phi plus has a, this has a dagger, so it would be phi minus, phi plus. Okay? And it's also clear because these are bosonic variables. If these phi's were fermionic, as for superstring theory, these phi's would be replaced by some Dirac spinor fields, Majorana spinor fields in 2 dimensions. They would be fermionic, and so let me write it. It is, I'm making a mistake. It is just a product. It is just a product of the two. Okay, there was no bracket. I'm sorry, it was a slip. Okay, you can tell me. So if I have psi plus times psi minus, then after I have written a Fock space decomposition for the field psi, and after identifying positive and negative frequency parts, if I were to write the normal ordered product for this, then this would be minus 1 into psi of minus, psi of plus. Okay? And this would actually also mean, these two would also mean that if I were to write a dagger, normal order product of this, then this would be plus 1. I am writing on purpose a dagger A. Supposing I have some operator C or D dagger, then this would be minus 1 D dagger D. So this is for a boson, this is for a fermion, this is for a boson, this is for a fermion. Is this okay? So whenever you write the normal ordered products, and also in field theory, also in string theory, also in superstring theory, right from the definition of your action, Lagrangian, all the way up to whatever you do, without saying at each and every step again and again, it is assumed that everything is normal ordered. Okay, so normal ordering has to be done always. Okay, and so with this normal ordering, actually it has its relevance with the vacuum. And so you basically measure quantities relative to the vacuum. That is the idea. Now, if I can make use of this, and let me just replace this first step by a complex scalar field where my L would be d mu phi, either star or dagger as you like, times d mu phi minus m square phi star phi. Okay, so if I have this, then I would simply make it b dagger. Okay, and then all these things would remain the same, but I would have additionally, so if this is my phi star, now you take its complex conjugate, or if you like b dagger, so this is b of k times iota goes to minus iota minus I k x, and plus this would give me a dagger of k, and this would give me, because I have two fields now, phi and phi star, therefore I will have two separate Fock space decompositions, right? Is this okay? So after, and here of course I mean these applications would apply to whatever fields you are considering. Okay, so for example, for this they would also apply to b dagger b. Okay, so if b dagger b here is b dagger would be plus 1 times b dagger. Okay, all right. Fermionic fields I will consider a little bit later. Okay, so this we need to know. And now let me come back to quantum mechanics and to real scalar field theory. Then things could be easily generalized and understood. Okay, so two things I am taking simultaneously. I am talking about quantum mechanics, which is one-dimensional harmonic oscillator only. And here in field theory, it's an infinite collection of, or a collection of infinite number of harmonic oscillators, if you like. Also for the real scalar field theory, also for the complex scalar field theory, and the same for the string theory and the superstring theory. And we would demonstrate it, okay? I will keep telling, all my entire story would be completely coherently related. Okay, and I would be answerable for each and every point. All right, so I think we need to talk a little bit on yes, here this definition actually this definition would get generalized of Poisson brackets. So if I have a field A of xt b of by t, and you calculate, so you call it equal time Poisson bracket, and we would calculate equal time commutation relations. Unequal time commutation relations lead to propagators. Okay, this we might not be discussing, but if needed I will come back. So equal time Poisson brackets, so how would you define them? no, summation over k, yes. And if I have ai bj, then summation over this. So del ai over abc del, let me see c. So this is a function of, no, this is a, this is zt, but I can put a subscript k here. Let me better leave this page here, so I depend only on my mind. This is xt del b of j by and t del of instead of b, let me, okay, let it be, I wanted to write, let me change it a little bit, okay. Let me write it for, instead of a and b, let me write it for 5x of t, 5, and here I let me put I and j, pi of t, and this is equal time was no bracket, so t here t and here t, they are the same, okay. So this del of phi I x of t